When we insert and delete nodes, we're going to use what are called rotations to restore the red-black property of a given tree. So what is a rotation? If you look at the figure on the top, you see the two types of rotation, right rotate and left rotate. And so the right rotate, what it does is it takes node X and it rotates it up to the top there. And so here we have node X, we have alpha, beta, and gamma, where alpha, beta, and gamma are subtrees. They're placed in their proper positions, and now X is the parent of Y. And if we want to make Y the parent of X, then we do a left rotation there. So let's see how the algorithm works. Here is the algorithm itself, and we'll walk through it. Okay, so let's start with this tree here. So we have, we have a parent, we have X, beta, gamma, and alpha. And we have the child pointers, and we have the parent pointers. Okay. Line 1, we're going to set a variable y. So that's line 1, and we'll set y to be the right child of x. All right. So now lines 2 through 4, we're going to turn the y's left subtree into x's right subtree. What does that mean? Okay, so let's rewrite our tree here. And y, gamma. All right. So line 2 through 4, let me change colors here, is what we're looking at. So x right equals y left. So y left is beta. So if you come back to the original tree, we can see that the left child of y is beta. And we're going to take that and we're going to assign x's right child to that. So this link here has been broken. So that's gone. And if that one is null, then we'll set its parent. The y left's parent is now going to be x. And nothing else changes. Everything else is the same. And let's see here. And y still points up to x. Okay, so that's lines 2 through 4. This is line 1. Now let's look at lines 5 through 10. What's going to happen here is we're going to update y's parent pointer. Yeah, I know it's kind of a lot, but there it is. X, y, and alpha, beta, gamma. All right. So none of this is going to change. Let's do our parents. Notice that beta doesn't point to y anymore. That was updated. All right, so line 5. The parent of y is going to point to the parent of x. Done. This is lines 6 through 7 are taking care of the root case. Let's look at lines 8 through 10. If x is the left child of the parent, then we're going to set the parent's left child to be y. In this case, x is the left child of the parent, and so the parent's x is the, well, whichever it is. It's ambiguous in this figure. So it's either the left or the right. And so we're just going to point to y like that. So that's 8 through 10, lines 8 through 10. Okay, and notice that y's parent pointer, that one there, is no longer pointing to x. It's now pointing to its new parent. And now all we have to do is hook x up to y, hook x's parent. Okay, so now in lines 11 through 12, let's change colors. We are going to set y's left to be x. Let's draw a new tree here. So this is lines 5 through 10. And then for the final here, and the parents. All right, and this is going to be lines 11 through 12. So if we look at line 11 up there, y's left is now going to point to x. That's that one right there. And x's parent is now going to point to y, and we're done. We've accomplished the left rotation.